Okay, so picture a star, but not just any star. A star so unbelievably massive, so powerful that when it dies, it doesn't leave anything behind. No black hole, no neutron star, it just, poof, vanishes. Today we're diving into a really wild new theory that might explain these cosmic ghosts, and it does it by totally rewriting what we think empty space even is. Let's get into it. You know, most stars, even the really big ones, they go supernova and leave some kind of cosmic corpse behind. But we're not talking about those. We're talking about the absolute titans of the universe, stars with cores that are dozens of times heavier than our own sun. For them, the story is, well, it's a lot more dramatic. Right. For these monsters, the end isn't just an explosion. It's complete and total self-annihilation, an event so violent it literally shreds the star into atoms, and nothing, absolutely nothing, is left. This is the whole mystery behind something called a pair-instability supernova. So how in the universe does a star just completely erase itself? To really wrap our heads around this new idea, we've first got to get a handle on the classic textbook explanation for how this cosmic self-destruction is supposed to happen. Okay, so what you're seeing here is a kind of cosmic chain reaction. Let's just walk through it. Inside one of these massive stars, the core is basically held up by the sheer pressure of light, gamma rays pushing out against the crush of gravity. But here's where it gets weird. In these supermassive stars, the gamma rays get so energetic that they start spontaneously turning into pairs of matter and antimatter. This whole process acts like a thief, just stealing the energy that was holding the core up. And when that support vanishes, the pressure just plummets. Gravity wins, the core collapses catastrophically, and that collapse is so intense it kicks off a runaway nuclear fire that obliterates the entire star. Gone. So the key here is this beautiful but incredibly violent sequence of events. The star's core basically goes soft, which lets gravity trigger a massive collapse, which then ignites this unstoppable explosion. That's the standard story. But what if the story isn't really about the star at all? What if it's about the space it's sitting in? All right, now we're going to pivot and look at this from a completely different angle. What if the real key to this whole explosion isn't what's inside the star, but in the actual fabric of the universe all around it? We usually think of a vacuum as, well, nothing, the ultimate emptiness. But this new idea, it's called dynamic vacuum field theory, or DVFT for short. It completely challenges that. It asks this really profound question: what if empty space is actually a real substance with its own properties? So DVFT says the vacuum is this dynamic, fluid-like field. Seriously, think of it like a cosmic ocean that fills everything, everywhere. And, just like the ocean, this vacuum can have properties like pressure, it can have stiffness, and you can even get it excited. And this right here captures the whole shift in thinking perfectly. It's no longer just a star floating in space. Now the space around the star is an active player in the game, a powerful medium that can actually decide the star's fate. So how does this new theory actually change our view of that star-destroying explosion? Well, it's interesting. It doesn't just toss out the old ideas. Instead, it kind of translates them into a completely new language, the language of the vacuum. Think of this table as our decoder ring. What standard physics calls radiation pressure, that force holding the star up, in this new language, that's just the stiffness of the vacuum fluid itself, being pushed on by the star's incredible energy. And that weird pair creation process? In this view, that's just the vacuum fluid converting some of its own energy into particles. And this is the most important part. The support failure that kicks off the whole collapse, that's the vacuum fluid itself suddenly losing its stiffness. It literally goes soft and gives way under the star's immense weight. So the main takeaway is this: the star doesn't collapse because of some internal quirk. It collapses because the very fabric of space holding it up fails. The vacuum fluid, when it's put under that much stress, starts leaking its energy into creating matter, and that just makes it too soft to fight against gravity. You get the same result, total annihilation, but the cause is completely different. Okay, so we've got a new language to talk about the same cosmic event. But, does it really change anything? Why is this new perspective actually important? And that is the question for any new scientific theory, right? I mean, if it doesn't make new predictions that we can go out and test, it's really just philosophy. But this is where DVFT gets super exciting. It's not just a fancy rephrasing. It actually gives us new clues we can look for. Because this theory frames the collapse as a property of the vacuum, it makes 3 really specific predictions. First, it suggests the exact size of stars that can do this might be different from what we currently think. Second, it predicts we might be able to see a unique warning signal, like a change in the star's vibrations, right before it goes kaboom. And third, it could change the link between the energy of the explosion and the elements it cooks up. These are real, tangible things our telescopes can now go hunt for. This whole new perspective really forces you to zoom out and ask a much, much bigger question. If the vacuum can have such a direct and violent role in the death of a star, what else is it up to? The final thought here is just kind of breathtaking. These incredible cosmic events, the complete and utter self-destruction of the biggest stars out there, might not be a story about matter at all. They could just be a glitch, a sudden softening in the invisible fluid of space-time that's all around us. And that leaves us with this really tantalizing idea to chew on. If the vacuum of space can trigger the universe's most powerful explosions, what else is it capable of? What other secrets about dark matter or dark energy, or maybe even the Big Bang itself, are hiding not in the stars, but in the empty space between them?